while we go to the next one.
Okay. What specifically can we do right now to re-engineer humans? That's a natural segue.
Yeah, there you go. What can we do right now? Okay, well, what right now to re-engineer humans? Well, I mean, I guess this sort of gets to the issue of what we mean by engineering, because, you know, like, I sometimes I think, you know, CRISPR has this allure of being something totally new. You know, you're changing genes. And I mean, if you've ever, you know, had almonds or tomatoes, I mean, you are eating, I don't know, genetic engineering. I mean, like if you've seen the wild relatives of almonds, or I mean, if you ate the wild relatives of almonds,
but that's by conventional breeding.
Conventional, sure, it's conventional breeding, but then what's happening at the level of of the genes? What's happening is that you're saying like, well, there are certain genetic variants that I like. That I'm going to combine, and I'm going to promote, and I'm going to basically, I'm you know, by breeding you're reconfiguring the genome of a plant or a dog or what have you. I mean, you know, it's you may not know the names of the genes you're playing with, but I mean, you can look at the genome of a dog and look at the genome of a wolf or a coyote, and you can see that, you know, we have massively changed their genomes, and we've changed those genomes for specific things that we wanted, like a wolf that won't kill us, you know, and well, things like that.
That lick our hands, you know.
And lick our hands, yeah. I mean, that's not, you know, you don't teach a dog to do that. That's in their DNA, and so I mean, so you know, the things. So I don't know. I mean, so the things that we can do right now to quote unquote engineer human DNA is say, I want to have children with this person instead of that person. I mean, you're making a choice. Now you're using a proxy of what they look like, how they strike you, and so on. I mean, we're not yet at the point where you're inspecting their genome, and you know, that's probably going to happen pretty soon. I mean, I heard in Iceland there's some app where you can, like, you know, if you're with someone in a bar, you can make sure that you aren't going to be carriers because there's such a small population. That's, you know, that's not that far in the future.
But when, you know, people get together to reproduce, they're basically engaging in a lottery. Nobody knows how it's all going to turn out.
Except, okay, what about in vitro fertilization with pre-implantation
That's exactly good for you. That's exactly where I was going to go with this. Because,
I'll let you take it from there.
Right. Well, you can now re-engineer in the following sense. So in vitro fertilization is a commonplace technology that's used largely by couples who are otherwise infertile that have children. So, and by the way, we should bear in mind that a long time ago, a brilliant geneticist and eugenicist named J.B.S. Haldane wrote a book called Daedalus that was published in 1924 in Britain, in which he basically argued that we could, in the future, expect to have test tube babies. He was very farsighted in that way, and IVF is a form of that. And he said, of course, people will resist that, but what was inadmissible in our biological lives yesterday becomes admissible today. So in the beginning of artificial insemination by donor, for example, people held that kind of technology to be a form of adultery. Surrogacy was greeted with very mixed reviews when it came along in the 1970s. And in vitro fertilization was charged with being a new form of eugenics. But these are now commonplace technologies used in our reproductive lives as a society. And you can imagine that, and we have, I think, the technology to do this now, having several eggs fertilized in a petri dish with sperm. And then if the family is at risk for a hereditary disease such as Huntington's, to do a genetic analysis of the embryo and then not engineer, in the sense of change the embryo, but simply select the embryo that doesn't have the bad gene. Okay, that's a form of re-engineering in the family.
Yeah, that is engineering.
That is engineering, right?
Just because it's a variation that our bodies kind of produce doesn't mean that we can sort of say like, oh, it's natural. We're saying like, okay, we're going to take the variation that we generate and we're going to make choices. We're going to say like, I'd
That's
rather
right.
not use that egg that is going to lead to, that has a cancer, gene, for example, that might lead to like just almost a certainty of very early cancers. And there are people who will do screening right now, regularly, to say like, nope, we're not going to use that one, we're going to use that one. And as soon as you're making those choices, I think you're totally engineering.
Well, I agree. I'm saying that this is a form of engineering. It's already upon us. And we exercise this kind of engineering even beyond the Petri dish when we do amniocentesis and then abort fetuses that are diagnosed for, say, having number 21 chromosomes, which gives rise to Down syndrome.
How much is that, would you say, how much does that tie into what you're describing as negative eugenics?
I don't think of it as a negative eugenics because we're not trying to improve the race, so to speak, or the population. We're only trying to allow people to have healthy children.
All right.
I think it's important to keep those distinct, those two ideas.
Ooh, this is a good question. How can today's biotech industry learn from the heyday of eugenics?